My name is Alexey Andreev. I'm a network engineer at Facebook, and I'm going to talk about our next generation data center network, the data center fabric. Historically, we've been building our networks in clusters. A cluster has 4 large cluster switches, a couple of hundred racks. It's a layer 3 network. Each dot on this diagram shows a server rack with a top of rack switch. It is a pretty large unit of deployment. We have many clusters in our typical data center. On the front, they push traffic to internet, to people who use our site and services. On the back, clusters talk to each other. Both types of traffic grow. How much they grow? You can see from this slide. This is our typical year. The green shows machine-to-user traffic. It increases, but its growth is dwarfed by the red, which is machine-to-machine traffic. And clusters have limits of how much machine-to-machine traffic they can accommodate, especially between the clusters. To lift these limits, we redesigned our network as a building-wide, one high-performance fabric. It's a very highly scalable network with much simpler components. Each dot on this diagram is a small and simple network box, much simpler than a large cluster switch before. There are many ways to picture it. All images here show exactly the same topology, just rearrangement of dots, but in reality, it's impossible to picture it to our actual scale. That becomes just a blur of lines. Let's look under the hood. Our fabric consists of server pods. Each server pod is like a microcluster. It aggregates a bunch of rack switches, but the number is much smaller than in clusters before. Parallel spine planes provide forwarding performance. Each can scale up to 48 spine switches. The fabric switches connect the pods and spines. The number of ports coming into a fabric switch can be equal to the number of ports going out, which can give us up to statistically non-blocking performance. For outside connectivity, we equipped our fabric with edge pods. Each can provide 7 terabits or more of bandwidth. We can have many edge pods, and we can add that dynamically as we need more capacity. The uplinks on the edge pods can scale to higher port speeds. Today, the links inside the fabric are 40 gig, but everything can scale to the higher port speeds as well. Fabric offers many parallel paths between servers. The way the fabric grows is by adding more spine switches and paths. Each path has equal performance. The load on the fabric is distributed. Different flows are taking different paths, coinciding on this large distributed infrastructure. Fabric can survive multiple device failures, component failures, link failures, without any production impact. Fabric offers us a very easy way to scale. When we need more compute capacity, we add server pods, which are easy units of growth. When we need more performance, we add spine switches on the planes. We automated everything related to the fabric, which made it very easy for us to deal with. We even changed the data center building design. We put the fabric at the core of the building, and we connect the data halls to the core by very simple straight line trunks as the data halls get constructed. This new architecture has been already successfully deployed in our brand new Altoona data center. The fabric is a highly scalable network. It offers us many times more capacity than what we had before, and it allows us to grow and higher. We automated everything about it, so it's actually simpler and easier for us to deal with than what the clusters were. And it's actually faster to deploy than the equivalent or even smaller amount of clusters. Check out the blog post for more details about our fabric and to learn how we got there. Thank you.